Welcome to Unit 10, Day 4, and today we are talking about a series. So the difference between a sequence and a series is just that a series is just the sum of terms. This is almost the same exact thing as sigma notation. It's just that the two special sequences we've learned about, arithmetic and geometric, have special formulas that can be used to perform a summation without using the summation symbol or calculating individual terms. So it's just a formula you can use to perform these sums without, I wouldn't say without using a calculator, but you can do without a graphing calculator that has summation in it. Let's take a look at the first two problems here. We are told to, given the following sequence, to find the sum of the first 5, 10, or 100 terms, so all three of them. Well, if we look at our sequence, we can see that this is an arithmetic sequence. Okay, which means we can write a summation formula for it based on the way it works. So we can write summation starting at term 0 up to term 4, because that's actually 5 terms. So let me just maybe give this a little more space. So we're going to go from, for an arithmetic sequence, we're going to write the summation of term 0 to the last term of the common difference times n plus our y-intercept, or our first term. So that's our formula. So let's just write that for this example. So that's the sum from term 0 to term 4 of the common difference, which if we look at the example appears to be 1, since it's increasing by 1, n, okay, plus our first term, which is 1. So if we were to run this on a calculator, we would get our answer. We could probably do this one by hand. It's pretty easy, just because of the numbers that we're using. Let's put a 4 and a 5 here. And if we were to add these up, that's 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 5 is 15. So that should be 15. Let's do this with a calculator. So if I press math, there's a button in mine. It's at 0. It says summation. So if I click that, I can write in this formula. So I'm going to use x for my variable. So that's 1x plus 1. As I press right, it brings me down to the bottom, where I'm going to choose x to be my variable. I'll press right, I'll enter 0, I'll press right again, and press 4. This might be different on another calculator. If I press enter, I get 15. If I press second enter on a TI, it'll allow me to rewrite the previous formula. So I'm just going to scroll to the left until it lets me change my index to 9. So that would be terms 0 to 9, which is 10 terms. So I can press enter and I'll get 55 for 10. And for 100, I need to make that into a 99. So I'm going to do second enter to bring up my previously entered expression. I'm going to change this to a 99, and I'll get 5,050. Now that's because the calculator has this quick feature that does summation, but there's a formula to use as well, which we'll talk about in a moment, because you wouldn't want to actually write out 100 instances of this sequence. So we're going to get the same answer using this formula for an arithmetic sequence, arithmetic series. So this means if you have an arithmetic sequence, you can use this formula and get that sum by hand. So step 1, we need to know the number of terms, which in this case was 100. Then we need to know A1, which is the first term, which is 1 in this case. Well, it's the first term. We used A0 really for the way we labeled it, but it's the first term plus the last term. So the last term in this sequence should be 101, because if we start at 1 as our first term and then we go up to 100 terms, it should be 101. But we'll calculate it just to be safe. All this divided by 2. So to find the last term, or the 100th term, we're going to start at the first term and add 1, which was the rule for this sequence, 99 times, right? So this should equal 1 plus 99, or 100. So the last term is 100. Okay, so that's the 100th term. So the first term is 1 and the last term is 100. So if I add those, I get 101. 101 times 100 is going to be 10,100. Divide that by 2, I get 50/50. So the rule is just the shortcut version of this is, so n is terms, however many terms you have. A1 is the first term. AN is going to be the last term. So it's the first term plus the last term times the number of terms, all divided by 2. Now, I'm not going to get into where this formula, well, I can get into where this formula comes from. It's if you list all the numbers, 1, 2, 3, etc., all the way down to the last number, which would be 100. If we were to write them backwards, we would get 1, then 99, then 2, and work all the way to the back, and we'd end with 100 here, and 99 here, and 98 here. And if you were to kind of group all the numbers in pairs, every time you add each of them, you get 101, which is the sum of the first term and the last term. So we'd get 100 of those because we'd have 1 for every number. So there'd be 100 101s, which is what this says. We have 100 101s, and because we can then just add up all the 101s, there are 100 of them, that means we actually added the sequence to itself twice. So the division of 2 is to cancel out the duplicate sequence. So the rule again is the number of terms plus times the first term plus the last term, all divided by 2. And that'll work for any number of terms in any sequence that is arithmetic. So let's take a look at the geometric sequence, which is the second example here. All right, now this sequence, you can usually tell that it's not arithmetic because it's clearly adding by a decimal, and it's not a consistent decimal, so it's probably geometric. So firstly, I need to find the R value. So to find the R value, I just take any 2 terms in sequence, and I divide the later term by the older term. So that's 2.02 divided by 2, and I should get 1.01, which is our common ratio. So if I wanted to do a geometric sequence, a geometric series, and add the terms for the first 5 terms for this, I would write the standard form for a geometric sequence. To add them as a summation, I can write n equals 0, so starting at the 0th term to the last term. And I'd start with my first term, whatever that is, multiplied by the common ratio n times. So in this case, I'm going to go from 0 to 4, so I'm going to write n equals 0 to 4, which is 5 terms. The distance between 0 and 4 is 5. My first term was 2. My common ratio is 1.01. And I'm going to do this, well, let's just skip to, well, yeah, we're going to do this n times. So if I calculate this, I should get a certain amount. So I'm just going to do this now with my calculator here. So I'm going to type in math. I'm going to go to the summation. I'm going to write the formula, which is 2 parentheses 1.01. Whoops, I left out a 0. 1.01 to the power of x. I'm going to fill this in to say x equals 0. And I'm going to make this 4. So this is adding these first 5 terms. I get 10.202. So if I were to add up the first 5 numbers in this sequence, that is the sum I would get. Now, there's a formula that's a little less weird than a summation formula, and on the Regents you would be asked to write expressions in the form of a geometric series. So I'm just going to show you that now. You'll notice there's an alternative method, an alternative formula, which just comes from the idea you need to find the last term in the arithmetic sequence. But for the geometric series, you only need to know the first term and the common ratio. So the formula looks pretty easy. It's the first term, which we know in this case was 2, times 1 minus the common ratio. I do need to put this in a parenthesis. So the common ratio is 1.01. We did 5 terms, so we're going to say 5. And then we are going to divide this by 1 minus the common ratio again, 1.01. We should get the same answer we got a minute ago, so let's just try that. So in my numerator, this calculator is not like a regular TI, so I can't do fraction mode on here, so I'm just going to be very careful. I'm going to make my numerator have its own parenthesis, so it's going to be 2, parenthesis, 1, parenthesis 1.01, close that parenthesis to the 5th power. Then I have to close this parenthesis. So that's my numerator. And I think I need one more parenthesis to close that. So this is the numerator. I'm going to divide that by parenthesis 1 minus another parenthesis 1.01. I'm going to close that. And I'm going to close the denominator. If I press enter, oh, I got a different answer. So either I made a typo somewhere or I made a mistake when doing this, one way or the other. Just looking for a potential error. I don't see one. Oh, I left out a minus sign when I did the example. I see it now. So let me write the numerator again. So my numerator is 2 parenthesis 1 minus, this is what I forgot, parenthesis 1.01, close that parenthesis to the 5th power. I have to close this one, and one more time, divided by parenthesis 1 minus parenthesis 1.01, close that twice, and press enter, and we get the same exact answer we did a moment ago, 10.202. All right, so that's pretty much how you can find the sum of any number of terms for either type of a series. So your examples down here are going to ask you to determine if an expression. It asks you to find, for an arithmetic sequence, to find the sum of the first 100 terms. That means we're going to say n is 100. And if you have a geometric series, to use the first 10 terms. And the reason for that is because a geometric series multiplies much faster and the numbers become really big. So 100 terms in a geometric sequence are probably going to make a number that's really, really, really big. With the exception of when you have a common ratio that is smaller than 1, you can actually add all infinite terms, but if it's bigger than 1, or you won't be able to do that. So this formula that I have here is only useful for infinite sequences, and we're not doing those. So in this case, we'll just look at the first term, the first sequence, and we can see that it starts at 2, and then the rule is add 2, which means this is an arithmetic sequence. And the first term is 2, and so our first term is 2, which we need to know. And we need to know the common difference, which is 2. And we need to figure out what the last term is. And since we're going to be doing term 100, A100, we need to find the 100th term. So the standard form for an arithmetic sequence is AN equals, the first term plus the common difference n minus 1 times, right? So if I wanted to find the last term, which in this case is the 100th term, A100 equals the first term, which is 2, plus the common difference, which is also 2 in this case, times n minus 1, which is 99. In other words, we're going to add 2 99 times to 2. So 2 plus 2 times 99. Whoops, hold on. 2 plus 2 times 99 is 200. So the 100th term here is 200. So that's what A100 is. So I now know the first and last term of my sequence, so I just have to use the formula, which is the number of terms, which is 100, times the first term, which is 2, plus the last term, which is 200, and divide this by 2, and I will get the sum. So using a calculator, that's 100 times 2 plus 200, which is 20,200, divided by 2, I get 10,100. So again, it's number of terms, which is n, the first term, and the last term. We'll do one geometric sequence series, and then you guys can try the rest of these on your own. So we're given this one here, where it's clearly geometric, because the rule is times 3. So we'll just use the formula. So it's the first term, which is 3, parentheses 1 minus the common ratio, which in this case is 3. And since we're doing a geometric, we're actually going to only find for the 10th term the sum of the first 10 terms. All of this is divided by 1 minus 3. So we'll just simplify this as much as possible. So the denominator is going to be 1 minus 3, which is negative 2, which is fine that there's a negative 2 down there. This is going to be a 3 here. And then we have 1 minus 3 to the 10th power. Okay, I just have to put this into a calculator, so I'll just do that now. So I'm going to do the more complicated part first. So I'm going to do 1 minus parentheses 3 to the 10th power. I'm just going to calculate this. I'm going to multiply it by 3, and I'm going to divide it by negative 2, and I get, oh, I left out the negative, so let me start it over. We're going to do, we'll just do it the way it is from the problem. So I'll do the numerator, and then I'll divide by the denominator. So it's going to be 3, let me just make it one expression. So parentheses 3, parentheses 1 minus parentheses 3, close that to the 10th power. I have to close that again, divided by 1 minus parentheses 3, enter, and I get 88,572. And that's only for 10 terms in this sequence, and that's just because geometric sequences get really large really fast. So try the rest of these on your own, and I'll take a look at the back with you now. All right, so problem 7 says to determine the number of terms in the arithmetic sequence, in the arithmetic series. So we're told we have an arithmetic series. The sum is Sn. There's some unknown number of terms here, so that means that we get 690 when we use the formula, the number of terms times the first term plus the last term. But we don't know what the term number is here, so this is what we're actually solving for. All we know is that the last term in this series is 96. So we're going to divide this by 2, because this is just the formula for calculating 690. So this is just an equation we can solve for n. So let's do that one now. So we have n, we have 690. Just going to make a separate section here. 690 equals 19 plus 96 divided by 2 is 57.5 n. So I'm just going to divide both sides by 57.5. So 690 divided by 57.5, and we get 12. So 12 is equal to n. So that means that there is a sequence that starts at 19 that has 12 terms that if you were to add them up, you would get 690. Try the other ones yourself. Problem 11 is the same problem with a geometric series, so that means that the sum of these terms, I'll actually start with problem 12 because I think this one's a little harder. So the starting term is negative 60. Well, we add up to negative 60, and that happens when you start with your first term, which is 3, multiplied by 1 minus your common ratio, which is given to us as negative 3. We don't know the number of times in which, the number of terms in this example. All of this is going to be divisible by 1 minus 3. So I'm just going to simplify this a little bit. So the denominator will become a nice number. So well, let's just start solving it. We'll simplify the denominator. So the denominator is going to be 4. So this is going to be negative 60 equals 3, 1 minus, I can't simplify this parenthesis because there's an exponent here that has to be dealt with first. So this is going to become 4. Next I'm going to cross multiply. So I'm going to get negative 240 equals 3 parentheses 1 minus 3. Zoom in a little more to the 10th, not the 10th, the n power, because again we don't know what that is. Next I'm going to divide both sides by 3 to cancel out this 3 here. And I'm going to get negative 80 equals 1 minus negative 3 to the n. I'm then going to subtract the 1 to the other side and get negative 81 equals negative of negative 3 to the n. I'm going to make both of these positive. So I'm going to get 81 equals negative 3 to the nth power. So what I'm being asked now is what power was negative 3 raised to? Well, we could write a logarithm, although logarithms tend to not work with negative bases. So if we were to write it as a logarithm, it would be log of base negative 3 of 81 equals n, but it's not going to work, and that's the reason I wanted to pick this problem. So if I do log base of negative 3 of 81, it should give me an error. It actually says something that's wrong, but we can actually just figure out what n is in this case. Negative 3 to the 4th power is 81, so 4 negative 3 should also do that. So n is actually 4 in this case. You can try the other ones yourselves. The remaining problems are all geometric series from the Regent exam, and you can try those on your own. And there are some problems to do on Delta Math. I will pull up Delta Math now and just take a quick peek at what they are. And these are the problems we have to do. We have a few more examples this time. So geometric series level 1. Okay, so you're asked firstly to find the sum of the first 7 terms. All you're going to do is it actually just gives you a formula. This formula is essentially the same as the formula that we have that I showed you guys before. The only difference is that on Delta Math they seem to have distributed the... Hold on, whoopsie, that shouldn't have happened. I want to keep track of my assignment here. Okay, so I'm just trying to open the assignment again for a new page. So the difference between the formula that I gave you, A1 is 1 minus r to the n, and the denominator is 1 minus r, is that they distributed the A1, so that should hopefully help avoid any confusion. So they had to find r using the same formula that I showed you for r, and then they just plugged in A7 for the exponent. That's level 1. Level 2. Let's take a look at level 2. They ask you to do the same thing, except this is actually an unknown number of terms. So, all right, so in this one it's calculator based. I actually think I'm going to remove this example from your assignment, so I'm going to take this away. But what they do is they find the common ratio. So they know the first number is 9. Then they find the next term. So they find 9. Then they find the common ratio is 5. So they just find the next term is 45, and they just keep going until they get to the last term in order to determine how many terms they are. Then once they knew it was 10, they plugged it in. But I'm gonna remove this assignment because that's just unnecessarily difficult. Next is the sum of a geometric series and sequence and context. These are going to match the word problems you have. So pretty much they're going to be giving you, like in this example, it says a major fishing company does its fishing at a local lake. The first year of the company operations, it managed to catch 184,000 fish. So that's the A1 is going to be 184,000. Then it says the number of fish the company was able to catch decreases by 5% each year. So that means the ratio is actually going to be equal to 1 minus 0.05. or which is equivalent to 95% of the fish remaining every year, so that's our R value. So if we were to use the formula, it would be 184,000, parentheses 1 minus 0.95 to the 11. All of this is over 1 minus 0.95. And then you would just calculate this with the calculator and round it to the nearest whole number. Last couple of things, got arithmetic and geometric series. Here I think this actually always gives us a, well, let's take a look what it gives us. So in this case we're asked to find the sum of the first 8 terms of the following series. So it shows us 36, 30, so it goes down by a different amount each time. So this is a geometric series because it wasn't a consistent one, so they just determined that the common ratio is 5/6, and then they just plugged it into the formula. Does it do any arithmetic series? I forget. Geometric. It does arithmetic as well, so you'll need to use both formulas here. And then last but not least, I put up some problems on doubling and half-life, which we did earlier in the term, so I just wanted to remind you how to do this. So a person invested $79,000 into an account, $7,900 into an account growing at a rate that doubles, so multiplies by 2 every 8 years. So that means until this becomes 8, until x becomes 8, it won't double. So if you're asked how much it would be after 5 years, that would mean you would have $7,900 times 2, but only 5/8 of the time period took place. So we would just calculate that using a calculator. And then the last problem type is the same thing, but solving for the number of years. So in this case, it says a new car was purchased for $18,000, and its value depreciates by a half, meaning multiplies by a half, every 3.5 years. So every 3.5 years, it would lose that much value. So the question is how long until it makes it to $900. So to do this, we would just have to use a logarithm. So I'm just going to erase the previous problem, and I'll go over this one. So I divide both sides by 18,000. We're going to get 1/2 of x over 3.5 equals, I'm just going to use my calculator for a second. So I'm going to do 900 divided by 18,000 and get 0.05. And then I'm just going to set up, I could do a logarithm, so I could say log base of 1/2 equals, I'll do it the way that they would probably do it. So I'm going to put a log on both sides, like we did in the previous assignment. So I'm going to put log here, I'm going to put log here, and then I'm going to bring down the exponent here. So it's going to become x 3.5 times log of 1/2 equals log of 0.5. Next, I'm going to divide both sides by log of 1/2. That cancels that out. So now I have x over 3.5 equals log of 0.05. I left out an O before. This should be 0.05. So log of 0.05 divided by log of 1/2. And then to cancel out the 3.5 on the other side, I'm going to multiply both sides by 3.5. So I'm going to do times 3.5 and times 3.5. Those cancel out. We're left with x equals log of 0.05. I left out the point, very important. 0.05. All of that is going to be divided by log of 1/2, and then multiplied by 3.5, and I get 15.126. And because the way this problem was asked, it says to the nearest tenth of a year, so it's probably going to be 15.1. All right, so let's see if they did it. This is mostly like this. All right, they divided by the 18,000, and then they did a log on both sides. They brought down the t over 3.5. I wrote x. They divided the log 1/2 to the other side, and then they multiplied the other side by 3.5. So same exact thing. If you have any questions, make sure you ask me in the private comments of Unit 10 Day